In this video, we are going to discuss the problem count pair with given sum. So the problem says that we'll be given an array and we'll be given a target as well. And the task is to find out the number of pairs in the array whose sum is equal to the target here. For example, let's take the first test case here. So suppose that we have been given the test case 1, 5, 7, minus 1 and 5, and the target element has been given as 6. So which are the elements or which are the pair of elements that I can add such that I can get the target sum as 6 here. If you will see, if I add 1 and the element 5, then I can get the target as 6. And also one more thing, if I add this 1 with the other 5 also, then also I can get the target. So you can see that I have found out two pairs so far. Another pair will be when I add this element 7 with minus 1, then also I can get the target sum as 6. Okay, so there are total three such pairs. So we have to do what? We have to count the number of pairs such that they can be equal to the target sum. Okay, so we have to count the number of pairs whose sum is equal to target sum. Now, how can we solve this problem? So the first approach is brute force, where we can try to generate all the possible pairs. Let's discuss that. So suppose that we have been given this test case and we can generate all the pairs here. Now, what do I mean by this? So basically, I can check this particular element with this element, then I can check the sum of this element with this element, then this with this, and this element with this element. Then after that, what I can do is I can check 5 with 7, then I can check 5 with minus 1, I can check 5 with 5 here. So this is how I can check. Now why am I not checking backwards? Because 1 and 5 have already been checked here. So I don't need to check 5 and 1 pair. So how can we do this? Basically, initially you can say that my I index will be standing here and my j will start from the next index. So my j will be here. Now is the sum of the ith and the jth element equal to the target? Yes. So my count will become equal to 1 because I have found one such pair. So this is the very first pair that I have found out. Now after that, my j will proceed further and my j will be here. Is the sum equal to target? No. So ask your j to move forward. Now j will be standing here. Is the sum equal to target? No. Ask your j to move forward. Now j is standing here. Now is the sum equal to target? No. Yes. Again, the sum is equal to target because you can see here that 1 and 5, these two elements are making the sum equal to the target here. So count will change to 2 now because there are two such pairs that we have seen so far. Then after this, my I index will proceed further and it will move to the next element. So now I is standing here. Now my j will start from the next index. Now when I check, is the sum equal to target? No. Ask your j to move forward. Is the sum equal to target? No. Ask your j to move forward. Is the sum equal to target? No. So your j will now end this iteration. Now after that, my I will proceed further and now my I will be standing here. J will start from the next index. So j will be here. Now when I take the sum is equal to target. 7 minus 6 is target. So 7 minus 1 is equal to 6, which is equal to target. So the count will be updated to what? 3 here. So count will increase by 1 because this is the third pair that we have found out, which is having the sum equal to the target sum. Then we'll ask our j to proceed further. Now is the sum of the ith and the jth element equal to target? No. Now j is outside the array after this iteration. So ask your I to move forward. Now my I will start from here and my j will be at I plus 1. Is the sum equal to target? No. Ask your j to move forward. It ends. And then after that, we'll not be able to find any such pair. So total number of pairs that we were able to find out is 3 here. Now what is the time complexity? If you see, for one particular index of I, we are iterating throughout the array, throughout the rest of the elements. So we are taking order of n time here for one index of I. So there are n indexes that we are iterating for. So we'll take order of n square time here. So the time complexity will be what? The time complexity for my approach is going to be nothing but order of n square, because we are iterating and checking all the possible pairs in this array, and the space complexity is going to be constant because I'm not using any extra space here. I'm just iterating throughout all the possible pairs. Let's discuss the code for this. If you will see here, firstly, we'll take the length of this array, then we'll make the counter initially as 0. Then we'll start iterating I from 0 till less than the length of the array. Then my j will start from I plus 1 till the end. And we'll try to check if the sum of the ith and the jth element, if it's equal to the target, then this means that this is a pair and we can count this pair. So we'll do count plus plus. At the end, after checking all the pairs, we'll return the counter here, which is going to be our final answer, because we had to return the count of the pairs which were having the sum equal to the target sum. Now let's discuss the optimal approach. Can we do it more optimally? Yes, we can. First of all, sort the array. So in a better way, if you have to like, भाई इसको cut कर देना. So let's discuss the better approach for solving this problem. The better approach will be that I can sort this array and then I can apply 2 pointers. Now this is a very beautiful approach and we'll try to understand this approach using multiple test cases as well. If you will see here, what will happen is, initially let's say my left pointer will stand here and my right pointer will stand here. First of all, I'll sort the array, because for applying 2 pointers here, I'll have to sort this array. Now after sorting the array, we'll put one pointer at the starting and another pointer at the end of the array. Now we'll take the sum of the left element plus the right element. What do I get? I get the sum equal to the target. Accidentally, if I'm adding this element and this element, I'm getting the sum which is equal to the target itself. Now what I should do is I should check, are there any multiple occurrences of these pairs, or there is only one pair. So what I'll do is I'll make a counter one variable. Initially it will be 0, and now since the current left element and the right element, they are making the sum equal to the target, so I'll count out how many minus ones are there and how many sevens are there. So what will happen is, initially my count will be 0, then I'll update the counter as 1. Okay, that there is one element which is minus 1. Then after that I'll move my left index forward, and you can see that there was only one minus 1, so the counter 1 will remain 1 only. Then after this what we will do is, we'll say that currently my element is 7, and the counter 2 will be equal to 1 because there's only one element, that is 7 here. And after this what we'll do is we'll decrease the right pointer, and now I am not at 7. So this means that there was only one element which was 7. So how many pairs can I make? I can only make one pair. No, I can only make one pair, that is minus 1 comma 7, which is having the sum equal to the target sum here. So what I need to do is I need to multiply counter 1 into counter 2. This is the number of pairs that I'll get. You'll understand this better in the next iteration. So initially in the counter what you will update is, since the elements were not equal, because minus 1 and 7 were not equal, so you will say that you will multiply counter 1 into counter 2 and you will add it in your answer. So the count will become equal to what? As of now, the count will become equal to 1 because there was only one such pair. Because 1 into 1 is 1 only. Counter 1 into counter 2 is going to be 1 only. Then after this, what will happen is, now my left and right pointers are standing where? See, now my left pointer is standing at this element 1 and my right pointer is standing at this element 5 here. Now what will happen here is, if I observe, so again the left element plus the right element, the sum is going to be equal to the target here. So this means that I have to again count the pairs. How will I count it? You might have just counted 1 and 5. Normally what you would have done, you would have just counted this pair 1 comma 5 one time and you would have moved. If you just directly count the pair directly and you just move your pointer, that is not going to be a good approach, because in that case you will miss out on a lot of pairs that should have been there. Because if you just count this 1 and 5 and then you move your left index and right index, you'll not be able to explore the other 1 comma 5 pair. So I want to explore all the pairs that can be made using these elements 1 comma 5 here. So what will happen here is, initially I'll say that my counter 1 will be equal to 0, and I'll try to count all the occurrence of this element, that is the element at the left index, which is 1 here. Now you will see here that there is only one element which is 1, so the counter will become 1 and my left pointer will proceed further after this. So my left pointer will come here. Now after that my right element was what? It was 5. So my counter 2 will be equal to 0 initially, and then I'll update it to 1, and I'll count all the occurrences of 5 by moving in the left direction. So I'll move in the left direction till I am at 5. So what will happen here is, in this case my right was here, then my right will come one step inside, it will come here, so the count will increase to 2, because there are two fives that I've seen so far. Then I'll decrease my right again, so my right will cross the left, and you can see here that as of now, like, my left and right are equal, so I can stop here because I don't need to proceed further after this. So what will happen is, now you can see that the counter 1 is equal to 1. What does that indicate? It indicates that the element at the left index, it was occurring one time. You can see that element at the left index initially was what? Element at the left index initially was equal to 1, and this element is occurring only one time. Now element at the right index was what? The element at the right index was 5. Now 5 is occurring how many times? 5 is occurring 2 times. So this means that how many total pairs you can make? You can understand one thing clearly, that you can make a pair 1 comma 5, and again you can make a pair 1 comma 5, because this one can make a pair with this 5 as well as this one can make a pair with this other 5. So there are two pairs that you can make. So the total number of pairs that you can make according to permutation combination logic will be C1 into C2, because if you have one element, if you have single one present here and two fives present, so the total number of pairs will be basically nothing but 2 here, because you have a 1 here and you have 5 and 5, so two pairs can be made here, na? So that will be nothing but 1 into count 1 into count 2, which is going to be what? Which is going to be 1 into 2. So 1 into 2 is 2 only, so the count will get updated by 2 more, so the count will be 3 here. And as of now you can see that the left and right have crashed with each other, so that is when we'll stop the iteration, and you can see that we have counted 3 pairs in total. Now you can see how optimally this was done, but there are several other things that we need to keep in mind as well. Let's discuss about them as well. Now understand one thing, that when we are applying these two pointers, so there can be several cases that can occur. What will happen is, suppose that if I have got an array here, and let's say my target element is what? Let's say my target element is 6 here, and as of now let's say we are at this element and this element, and there are several other elements in between as well. So let me write this properly. So let's say we are writing some elements like this here. Okay, now assume that as of now I'm at this left index and I'm at this right index. Now if my sum of the left element plus the right element, if it is greater than the target, because as of now you can see my sum is what, my sum is 11. If my sum is greater than the target, then I want to do what, I want to decrease my sum. If I want to decrease my sum, then I'll move on the left side. So if the sum is greater than the target, you know that we need to do right minus minus, because we need to move inside. If the sum is greater than the target, you want to reduce the sum. So you will go to a lesser element. So in that case, you have to reduce your right pointer. Correct. But suppose that the scenario was like what? If we had an element like, let's say if my pointer was somewhere here. Suppose that if I had an element, let's say 4 here, and my right was standing here. Now, if my sum of the left element plus the right element, if it is lesser than the target, if the sum is lesser than the target, what does that mean? If the sum is lesser than the target, then I want to increase my sum. If I want to increase my sum, then I'll do left plus plus, because I have to move on the right side so that my sum can increase, it can become closer to the target. These are two basic things that we always do. But what happens when the sum was equal to the target? So we have done this already, but let's do this again. Suppose that my sum was equal to the target. So let's say if I had the elements, that is, let's say we had some elements on the left side, suppose. Then after that, we had several elements too here. Let's say we had several elements like, let's say we had an element like 1 and 1. Then after that, let's say we had 2 also. Then after that, we had, let's say, something like 5, 5, 5, and 5 here. Okay, now assume that if my L was standing here and my R was standing here at some point of time. Now what will happen here? If you see, so when we add these two elements up, when we add the element at the left index and the element at the current right index, the sum is equal to what? The sum is equal to the target. So how many pairs can I make? I have to check all the possible pairs of 1 and 5 here. So what will happen here? You will see that when I'll apply the counter 1, it will count all the occurrences of this left element here. So when I'll apply it and I'll move my left pointer here. So currently I'm at 1, so I'll count it. Then I'm at 1 again, I'll count it, and then my left pointer will come here. So the number of occurrences of 1 is how much? Number of times 1 is occurring is 2. So the number of times the left element is occurring is 2 here. Then after this, what will happen is, we'll say that the counter 2, that is the counter for the right element, it will be what? Like we'll keep on iterating here. So we'll keep on moving towards the left side and we'll keep on counting this element 5 here, whatever number of times it is occurring. So we'll count, this is 5, this is again 5, 5, 5. So then my R will come here. Okay, so it can come anywhere. We can have several elements in between as well. But suppose that we had only 4 fives that we had. Okay, so we have the count of the right elements is basically going to be 4. How many pairs can I make? I can total make basically 8 pairs, because if you see here, I have got 1, 1, and I've got 5, 5, 5, 5 like this. Now the first one can make pair with other fives, right? And the second one can also make the pair with all the other fives. So how many pairs in total you should count? In total you should be counting a total of 8 pairs, correct? So that is nothing but C2 into C1. So the count should get updated by what? Count plus is equal to C1 into C2 basically. This is going to be what? This is going to be, you can say 2 plus 4. So the count will get updated by 8 value, because there are total 8 pairs that I have found. And notice one thing, that as of now, the element at the left index, okay, the element at the left index, you can say it is not equal to the element at the right index. So if the element at the left index was not equal to the element at the right index, and you were able to add the left index element plus the right index element, such that you were getting the target and these elements were not the same, then in that case count how many times the left element is occurring and how many times the right element is occurring, and keep on moving your pointers respectively. And whatever is the counter 1 and counter 2, which is indicating the occurrence of the left element and the right element respectively, multiply them up to find out the number of pairs that you will have, which will make the target sum here. Okay, but there is one more thing that you need to understand. Suppose that this is the case when the left element and the right element, their sum is equal to the target, but they are not the same. The left element and the right element are not the same. So in that case, the counter 1 came out as 2, because the left element was occurring 2 times, the right element was occurring 4 times. So the total number of pairs that I could make was C1 into C2 in this case, when the elements were not the same. But sometimes the element can be same as well. What do I mean by this? Suppose that, guys, let's say if my target was what? Assume that if my target was equal to 6 only, and suppose that I had several elements on the left side, and then I had 3, 3, 3 like this. Let's say something like this was there, and we had several elements here. Now after this, let's say my L was standing here and R was standing here. After some iteration, suppose my L is standing here and my R is standing here. Now what will happen in this case? If you will see here, so initially my counter 1 will be what? Like both the elements are same and they are making the sum equal to target, because when I add 3 and 3, I'm getting the target as nothing but 6 here. So you will see here that when I'll apply my counter logic here, so initially what will happen, counter 1 will be there, and it will keep on counting all the occurrences of this element 3 here until I reach the right pointer, because all the elements are same. So my left will keep on counting, and it will reach till this point. So how many elements are there? If you see, initially my L was standing here, then it will move forward one by one. It will keep on moving, and it will move till this point. So the counter will be 1, 2, 3, 4, then 5 and 6. So total number of times 3 is occurring is 6 times. So you can say that the count 1 is equal to 6. Basically, the number of times 3 is occurring is 6 here. And then the counter 2 will remain 0 only. Why? Because I will not allow it to move forward from here. The reason being because both the left and the right element are same. So I can only rely on the counter 1 because both the elements are same. So counter 1 will tell me the total number of occurrences of this element, which is same at the index L and the index R initially. Okay. Now, how many pairs can I make? If you see here, so I have got, like, if I have got 6 times 3, I've got 3, 3, 3, 3, 3. How many pairs can I make? Understand one thing. This guy can make a pair with this guy. This guy can make a pair with this guy. This guy can make a pair with this guy. This guy can make a pair with this guy. And this guy can make a pair with this guy. So the first guy can make the pair with 5 people. Understand one thing, that the first guy can make the pair with 5 people. Then the second guy will make the pair with how many people? The second 3 will make the pair with the, like, second 3 will make the pair with the rest. It has already made the pair with the previous guy. So it will make the pair with the rest of them. So this guy is going to make pair with this guy, then this guy, then this guy, and then this guy as well. So 4 times you are going to make the pair. Then the next 3 that is there, this particular 3, it is going to make the pair with next 3 elements. So this guy, and this guy. So plus 3 will be done. And after that, if you see, this particular 3 is going to make the pair with other 2 elements on the right side. So plus 2. Then the second last guy is going to make a pair with this last guy. So plus 1. So you can understand that what is this series looking like? 5 plus 4 plus 3 plus 2 plus 1. It's a decreasing arithmetic progression. And what will be the sum for this? It will be basically, if you see here, this is basically what? This is basically C1 minus 1, because actual C1 value was 6. So this is what? This is basically C1 minus 1 plus C1 minus 2 up till where? Up till you reach 1. So what is the sum of the series of C1 minus 1 plus C1 minus 2 up till 1? So the sum of the series is basically nothing but C1 minus, this is basically AP. So it will be C1 into C1 minus 1 divided by 2. Why? Because understand one thing very clearly, guys. This series is the sum of n natural number series. So let's say if I had a normal series, let's say if I had a series like 1, like p plus p minus 1 up till, let's say, 1. Okay, if this was the decreasing series that I had, what will be the sum for this series? This series will be p into p plus 1 by 2. Normally the series looks like this, but in this case the series starts from where? The series is starting from c1 minus 1, c1 minus 1 plus c2 minus 1. Sorry, c1 minus 1 plus c1 minus 2. It is decreasing like this, c1 minus 1 plus c1 minus 2 till you reach 1. So instead of p, what you will do is, instead of using p, you have to put c1 minus 1 here. So this will be what? Because the sum of the natural number series p plus p minus 1 up till 1, it is p into p plus 1 by 2. Now replace this by using mathematical approach, that instead of p you have to write c1 minus 1. So it will be what? C1 minus 1 into what? C1 minus 1 plus 1 divided by 2. Okay, so this will be what? This will be C1 minus 1 plus 1 divided by 2. So this is going to be what? This is basically going to be nothing but, you can say, C1 minus 1 into C1 divided by 2 into C1 divided by 2. So these are the number of pairs you will get when the element at the left index and the right index are same, and the counter 1 is going to decide the answer here. Okay, so you can see here total number of pairs that we'll make is like it will be like 6 into 5 divided by 2. So it is going to be what? It is going to be 15. Total 15 pairs will be made. You can try them out. Total 15 pairs will be made, because you can see normally also 5 plus 4 will be 9. 9 plus 3 will be what? 12. 12 plus 3 will be 15 here. You can understand this using some basic case also. Let's say if I had only 3 threes. Suppose that if initially I had only 3 threes and my left was here, right was here, then the count 1 would have been equal to what? Then my count 1 would have been equal to 3. If there are 3 threes, how many pairs I can make? This guy can make a pair with this guy. this guy can make a pair with this guy, and then this guy can make a pair with this guy. So total 3 pairs would have been there. So if you see C1 into C1 minus 1, that is 3 into 2 divided by 2, this is going to be what? This is going to be 3 here. So total 3 pairs are made. So the number of pairs that will be made if the element at the left index and the right index are same, it will be C1 into C1 minus 1 divided by 2 here. I hope that this is very much clear to all of you. When the elements are not the same, then the counter 1 into counter 2 will be the number of pairs that you can make. For example, 1 was occurring 2 times, 5 was occurring 4 times. Total number of pairs that you can make is 8 in that case, using 1 and 5. But if the elements are same, if the left and the right element are same initially, then you will find out the counter 1, that is the times number of times this common element is occurring, and then the number of pairs will be counter 1 into counter 1 minus 1 divided by 2. I hope this makes sense. Let's discuss the code for this as well. If you will see here, what we will do is, firstly we'll declare the result initially as 0, then after this we'll find out the length, then we'll update the left as 0, right will be at n minus 1. We'll iterate until the left is less than right, because when they clash, then we have to stop. If the sum of the two elements, if it is lesser than the target, then we have to increase the value. So we have to increase the sum value. So we have to move our left pointer. But if the sum is greater, suppose if the sum is greater, then we have to decrease the sum. So we have to decrease the right pointer in that case, because we need to go to a lesser element. Otherwise, if the sum is equal, then there are two things that you need to care about. If the sum is equal, then initially what you will do is you will update the counter 1 as 0, counter 2 as 0, and you will get the respective elements at the left index and the right index. Okay, once you have got those elements, then you will say that counter 1 will count the number of times the left element is occurring. So you will say that while the left is less than equal to the right, and the initial element that you found out at the left index, if it is equal to left, you will keep on counting it, keep on increasing your left and keep on increasing your counter 1. Then after that, count how many times your right element is occurring. Okay, so initially you have updated the element 2 to the right element, and then you keep on decreasing your right pointer and count the number of times that your right element is occurring. Now after that, you have to check if the original left element and the right element that were making the sum, if they were same, then the result will be what? Then I've discussed that the result will be counter 1 into counter 1 minus 1 divided by 2. If both the left and the right elements were same, in that case, how many pairs will be contributed? In that case, the number of pairs contributed will be counter 1 into counter 1 minus 1 divided by 2. I have proved this arithmetic progression as well. So I hope you understand this. Otherwise, if the two elements are different, then the result will be updated as what? Then the result will be updated as counter 1 into counter 2, because you can see both the test cases I have explained. When the left and the right element are same, then it will depend on the counter 1, because if 3 is occurring 6 times, so total pairs that you can make is 15 here. So counter 1 into counter 1 minus 2, sorry, counter 1 into counter 1 minus 1 divided by 2. And if the left element and the right element are distinct, so total number of pairs that you can make is counter 1 into counter 2. That is the pairs that you can make. 2 into 4, that will be 8 here, because total pairs that you could make for 1 and 5 is 8 here. Now, if you see here, this is again a two-pointer approach only. So what is going to be the time complexity for this code? Initially, we are going to sort the array. So that is going to take order of n log n time. Plus, after that, we are going to iterate using 2 pointers and count all the possible pairs. So using the two-pointer approach. So two-pointer is helping us to efficiently count the pairs without checking every pair individually. So that is the advantage here. That is why we'll take order of n time after sorting. And this overall is going to be n log n only, because n log n will dominate here. The space complexity is going to be constant, because we are not taking any extra space here. We are just using the variables here. We are not taking any extra data structure. Now, can we solve this problem more optimally? Yes, we can solve this problem more optimally using the hash map approach. So what we can do is, whenever we come across any element, we can count the number of occurrences for that element, and that will help us. How? Let's understand. So if you see here, let us say that initially I'll be at this element 1 here. So I will check for the complement element. So let's say I'll check for the other element or the complement element, that how many times the complement element or the other element that I expect is occurring. So if I'm at 1, what is the other element that I expect? So it will be target minus ARR of 5, let's say. So right now my target is 6. 6 minus 1 will be 5. So I'll check, is 5 occurring inside the map? No, 5 is not occurring inside the map. So then I'll say that, okay, let's update 1 inside the map and move forward. So inside the map, what I'll do is I'll update the frequency of 1 as 1, and then I'll move forward. Okay, now next time I'll be at this particular element, that is 5. Now when I'm at the element 5 here, what is the other element that I expect? The other element that I expect is basically 6 minus 5, that is 1. Now we have to check that how many times one has been seen so far. So one before this 5, one has been seen only one time. So in the map it says that one has been seen only one time. So update the counter with the occurrence of the with the frequency of the element 1. So the count will be what? The count will become 1 here. So you can say that every time we'll do what? Count plus is equal to MP of this other element here. The number of times this other element is occurring. So the count initially will be updated to what? It will be updated to 1 here, because 1 was occurring one time only. Then after this, we'll update the frequency for 5 inside the map as 1. Now next time I'll be where? Next time I'll be at this particular element, that is, let's say 7. Now when I'm at 7, so what is the other element that I expect? The other element that I expect is -1. But is -1 present in the map so far? No. So I'll say that, okay, let's put this ith element in the map and let's move forward. So we'll put 7 inside the map since it's coming for the first time. Frequency will be 1 here. Then after this, what will happen is we'll move to the next element, and the next element will be 1 here. Okay. Now when I'm at, sorry, next element will be -1. Now target is 6. The other element will be what? The other element will be 6 minus -1, which will be 7. So if I'm at -1, the other element that I'm looking for, or the complement element that I'm looking for, is basically 7. Have I seen 7 before this? Yes. How many times I have seen it? I've seen 7 one time only. So add one more to the answer, because this -1 can make a pair with the 7. So add 1 to the answer because 7 was occurring one time before this index. Okay, then what we will do is we'll update the frequency for this element as well inside the map. So now what will happen is frequency for -1 will be updated as 1 here. Then we'll go to this element 5 here. Now the moment we go to this element 5, so what is the other element that I expect? The other element that I expect is 6 minus 5, that is basically 1. Now have I seen 1 before this in the map? Yes. How many times I've seen it? I've seen it one time. So this 5, currently I'm at this 5, it will make a pair with this guy. So the number of times 5, number of times 1 is occurring inside the map is basically 1. So this particular 5 that I'm currently at, it will help me to make one pair, because there's one occurring only one time here. So I'll make a pair here. So the counter will get updated with the frequency. So what will happen here is counter will get updated with the frequency of 1, that is 1 only. So plus 1. So you can see that the counter is 3, and then we reach the end of the iteration here. So this is how it works. Basically, by keeping a track of the number of times an element is occurring, you'll be able to count the pairs easily. Now let's do it on a test case which is different, because this was an easy test case. Let's do the same dry run on a different test case. So what we will do is let's change the input here. Let us say that if I had what? If I had, let's say, some elements that were, let's say I had 777 only. Or let's say if I had something like, let's say 333. So what will happen here is when I'll come initially, when I'll be at 3, what is the other element that I expect? 6 minus 3, that will be 3. Before this, have I seen 3? Before this, have I seen 3? No. So then it is not present in the map. So we can say that, okay, we'll put this ith element inside the map with the frequency as 1 and we'll move forward. Now after that, what will happen is when I'll be at this particular element, so when I come across this second element 3 here, then the other element that I expect is also 3. So I'll check inside the map that how many times this 3 was present earlier. So 3 was present in the map one time. So this means that this 3 can make a pair with this guy. So the counter will be updated with 1 here. Okay. And before moving from this index, we'll update the frequency for this particular element. So the count for 3 will become now 2. Okay. After this, we'll move to the next index here. So you can see that this 3 has made a pair with this guy. Now after that, we move on to this particular element here. That is 3. Now when I'm at this element 3 here, what is the other element that I expect? The other element that I expect is nothing but 3 again. So I expect the other element as 3 here. Now how many times 3 has occurred before this? So I'll check in the map. Map will tell me that before this 3, before seeing this 3, how many times my complement element has occurred. So how many times my other element has occurred before this index. So you can see that before this index, the other element, the complement element, has occurred 2 times. So this means that this 3 can make a pair with this guy and this 3 can make a pair with this guy and be equal to the target sum. So that is why the count will get updated to the frequency of the complement element. That is 3's frequency is 2. So plus 2 will be done here. And you can see total count will be 3 because total 3 pairs will be made. Firstly, you can see here that this 3, the green symbol that I have highlighted, then the 2 yellow ones. So these will be the total 3 pairs that will be made here. I hope this makes complete sense to all of you. Okay, let's do a dry run on one more test case so that things are more clear. Now, let us say that if I had what? If I had another test case which was something like this. Let's say if I had something like 1, 1, 1 here and then I had 5. Now, if you see here, when I'll be at 1, I will see that the complement element, the other element 5 is not there. When I'll be at this one, I'll see that 5 is not there. I'll be at this one, I'll see that 5 is not there before this. So by this time, the frequency of 1 will be what? By this time, the frequency of 1 would have been 3 in the map. And then the moment I reach this particular element, that is, let's say 5 here, So I'll check what is the other element that I expect. The other element that I expect is 6 minus 5, that is basically 1. So I'll check how many times this other guy is occurring. How many times this other guy is occurring? The number of times this other guy 1 is occurring is 3. So this means that this 5 can make 3 pairs because there are 3 ones, so it can make 3 pairs in total. So whatever is the frequency of the other element, that you need to update in the counter. So counter will get updated by 3 here. And you can see that total 3 pairs can be made. I don't have any obsession with 3, but accidentally the test cases that I don't have any obsession with 3, but accidentally the test cases that I took, they were having the answers as 3, but the answers can be different as well. Now let's see the code as well. If you will see here, we'll have a frequency array. Then we have the counter initially as 0. We'll iterate for all the elements here, and we'll check for the complement element or the other element. That will be target minus ARR of I. If it is present in the frequency map, then what I'm going to do is whatever is the count or whatever is the frequency for the complement element, I'll update my counter or I'll update my result with that much value. Okay. And after that, every time before moving away from this ith element, I'll update the frequency of this element in the map. So if it is coming for the first time, its frequency will be updated as 1. If it was already there, then whatever was the previous frequency plus 1 will be done to it. So you can see here, if it was already there, then whatever is the frequency for this guy plus 1 will be done. But if it was not already there, then 0 plus 1 will be done. So the frequency will be updated as 1 if it comes for the first time. At the end, I'll just return the counter here. Now you can see this is much efficient because I'm just going to iterate in the array and use hash map here. So the time complexity for this approach will be basically order of n because I'll be iterating throughout all the array elements here. Okay, and I'll be using hash map. So for checking the element is present in the hash map or not, it will be constant time complexity for me. Now space complexity will be order of n as well here because in the worst case I'm going to store all the n elements of the array inside the map here. So let us submit this code and see if it is getting accepted or not. So you can see that the code is getting accepted. I hope that you are clear with this particular question, and make sure to comment understood if you have understood this clearly. Thank you for watching this video.